Okay, so here in this video, I'm going to go over the solutions to some derivative rules, okay? So here we go. Let me just see if I could hide that right there. All right. So to use the power rule, we've got to have the form of x to the nth power. And once we do, that derivative of an expression or a function of that form is found by dropping down the power, multiply it by the constant in front, maybe call it a, repeat the x, and decrease the power by 1. So here in number 1, we have that. So f prime of x would be, can't see, 6x squared minus 8x plus 1. The second derivative, the derivative of the first, would be 12x minus 8. Again, 3 times 2 is 6. Repeat the x, decrease the power by 1. The derivative of any constant is 0. And the reason why that is, the slope of a constant line, which is straight across, horizontal, is 0. In number 2, I cannot do my rule yet until I distribute using algebra. So it'd be 8x to the 5th minus 2x to the 3rd plus 2x squared. Now I have individually x to the nth power, and the derivative will be 40x to the 4th minus 6x squared plus 4x. In number 3, I cannot do my power rule until I distribute. I'm going to rewrite this as x to the 1/2 times x squared minus x plus 2. When I distribute, I got to add the exponents. So 2 plus 1/2 is 5/2. 1 plus 1/2 is 3/2. And 2 times x to the 1/2 is 2x to the 1/2. Notice I didn't even take a derivative yet. All I did was rewrite this product as individual terms of x to the nth power. Now I'll take my derivative. So I'm sort of running out of room here, so I'll drop down the power. That's going to be f prime is 5/2. Repeat the x. But the way to decrease a fraction by 1 is to easily go minus 2 over 2, which is 3/2. Minus drop down the 3/2. Repeat the x. Minus 2 over 2, or 1/2. And then 2 times 1/2, I hope we know, is 1. And then minus that 2 over 2 is x to the negative 1/2. In number 4, I'm just going to drop down my powers. So it's going to be 2 times 1/3. X minus 3 over 3 is minus 2/3. Minus 4 times that power of 3/4. Repeat the x. And minus 4 over 4, which is minus 1/4. And I'm okay with the negative exponents here. So it'd be 2/3 x to the negative 2/3. And those 4's divide out with 3x to the negative 1/4. In number 5, I need to use algebra first because I'm using the power rule only. So that means I'm going to square this, which is 4x to the 4th, multiply these, but double it. So that's minus 4x to the 3rd plus x squared. And f prime of x is going to be equal to 16x to the 3rd minus 12x squared plus 2x. And the second derivative of that is pretty easy for me to fit here. It'd be 48x squared minus 24x plus 2. In number 6, I'm dividing. So I'm going to create x to the nth by subtracting the exponents. So f prime of x equals 4x to the negative 4th. 4 minus 8 is negative 4. Minus 3x to the negative 5th. Minus x to the negative 6th. Plus x to the minus 8th. Again, just subtracting the exponents. The top minus the bottom. And I made a little mistake there because this is not the derivative yet. So f prime of x will be found by dropping down the power, negative 16x to the negative 5th, plus 15x to the negative 6th, plus 6x to the negative 7th, minus 8x to the negative 9th. Over here, well, it gets a little dicier. I need to subtract these exponents again. So this is going to become 3x. Now this power of 1/2 minus 2 is negative 3/2. And 1/3 minus 2 is negative 5/3. So this would be x to the negative 5/3. And if you don't know that, just times this by 3 over 3. You get 1 minus 6 over 3, which is negative 5/3. But again, I got to be careful here. I did not even take a derivative yet. So y prime would be 3 times negative 3/2 x. Subtract 2 over 2 because you're decreasing it by 1. And then just hard for me to see, minus 5/3 x. And subtract 3 over 3, which would be negative 8/3. In number 8, I do not have x to the nth until I square this first. And I'll get 9x squared minus 12x plus 4. Now I'll distribute just using good old-fashioned algebra to create that x to the nth power. And this is y rewritten. Now that I have individually x to the 9th, the derivative would be 36x cubed minus 36x squared plus 8x. Now in part 2, we are to differentiate using what is known as the extended power rule. The extended power rule. We're going to extend the power rule over a quantity. And you can get this right if you can count to 4. The first step is found by dropping down the power in front and multiplying. That's step 1. Step 2, repeat the inside. Step 3, decrease the power by 1. And step 4, the most important part that cannot be forgotten, is the derivative of the inside stuff, which is negative 4. To clean this up, negative 4 times 6 is minus 4 times 1 minus 4x. Try number 10 on your own. See what you can do and pause the video. So f prime, drop down the power and multiply as 1. Repeat the inside, which is 2. Decrease the power by 1, which is 3. But the derivative of the inside, I have to invoke the power rule. So the derivative of x to the 1/2, drop down the 1/2, repeat the x, decrease it by 1, negative 1/2. And the derivative of x squared is minus 2x. Over, and you can leave it like that. Number 11, f prime of x equals, drop down the power. That's going to give me what? Negative 8/3 is step 1. Repeat the inside is step 2. Decrease the power by 1. It's negative 1/3. And times it by the derivative of the inside stuff. So your all eyes are on the inside stuff. It's another derivative rule. It's the power rule again, but on the inside. The derivative of 3x is 3. Drop down the power. 6 times 1/2 is 3. Repeat the x. And when you take 1/2 and decrease it by 1, you get negative 1/2. In number 12, I'm going to have to rewrite this as 3 times 4 plus 2x to the second power. It's not of the form. I have a quotient here, and I'm not doing the quotient rule. So 4 things. Drop down the power, repeat the inside, decrease the power by 1, and times it by the derivative of the inside. And that would be easily cleaned up to be 12 times 4 plus 2x. In number 13, again, 4 things. Drop down the power and multiply. Repeat the inside. That's only 2. Decrease the power by 1. That's now 3. And the derivative of the inside is multi-step, but it's that fourth step. It's the derivative of the inside. So -2, drop down the 1/3, repeat the x, decrease that by 1, which is -2/3, drop down the 1/2, repeat the x, and decrease 1/2 by 1, which is -1/2. And number 14, again, 4 things. The derivative will be 4 parentheses, let's drop down the powers 1. I'm just going to copy the inside. Pretty easy step. Decreases power by 1 is step 3, but now the derivative of the inside. So this would be -14x to the -3rd. I'm going to make this 2x to the -1st, because to do the power rule, it has to be x to the -1st. So that's going to be -2x to the -2nd. And I'm going to rewrite this as 3x to the -2nd. So that becomes my power rule. And this will be plus 6x to the -3rd. And the very last two for this assignment is a tangent line. I really want you to copy the same structure I have for a tangent line. And here's how this is going to roll out. For a tangent line, we write down it triggers a slope and a point. Slope and a point. Please follow the structure here. When x is 1, y is found by subbing it in. So that's not too bad. 3 minus 1 plus 1 is 3. My slope of the tangent is the derivative. And this derivative is 6x minus 1. But the slope at that point when x is 1 is found by subbing 1 in. So 6 minus 1 is 5. Now, how I'm going to set this up is don't use that y equals mx plus b stuff. I'm going to do y minus the y coordinate, which is 3, over x minus the x coordinate equals my slope. It's the point slope form. I'm going to cross multiply to get y minus 3 equals 5 times x minus 1. I'm going to distribute and add the 3. And there it is right there. And then at number 16 over here, again, the tangent line triggers. I can't tell you how much this has helped my students over the years. Slope and a point. So this is when x is 4, and to get that output, I'll sub this in. The square root of 4 is 2, times this 2 is 4. Again, my slope of that tangent line is the derivative, the instantaneous rate of change. In this derivative, getting a little small here, I'm going to rewrite this as x to the 1/2, drop down the power, 2 times 1/2 is 1, repeat the x, and decrease that by 1, which is -1/2. So that's going to come out to be 1 over root of x. So this is a situation where you have to evaluate the derivative. You do not want the exponent to be negative. You want to kick the base and its exponent down to the denominator. So it becomes 1 over root of x. And when x equals 4, my slope is 1/2, because the square root of 4 is 2, so it's 1/2. But I didn't find the line yet. So it's going to be y minus this 4 over x minus that 4, which equals 1/2. And we solve a proportion by cross multiplying. So it'd be 2 times y minus 4 equals 1 times x minus 4. And I distribute the 2 through. Add the 8. We want a little bit of room here. And then divide by 2. And my answer is 1/2 x plus 2. And again, please follow that same structure for a tangent line, slope, and a point. And that concludes the solutions to homework number 14.